An object moves horizontally and follows an equation for its location in meters as a function of time in seconds as x of t equals t cubed minus 6t squared plus 9t. T is between 0 and 5 inclusive. Determine the parts A through G. So our position as a function of time, x of t, is t cubed minus 6t squared plus 9t. For part A, we want to find the velocity as a function of time. The velocity as a function of time is the derivative of the position as a function of time. First term is power rule, bring down the power, subtract 1 from it. Second term is power rule, bring down the power, multiply with the negative 6, subtract 1 from the power. Third term is a constant times t, the derivative is the constant. For part B, we want to find the time or times when the velocity is 0, so we're going to set the velocity function of t that we just found equal to 0. There's a common factor of 3. We'll factor that out. And then we can factor the remaining portion using trinomial factoring, t and t. We need two numbers that multiply to be a positive 3 and add to be a negative 4, and negative 1 and negative 3. We'll make that happen. So it looks like we have t equals to 1 second and t equals to 3 seconds. For part C, we want to know the maximum horizontal location reached, and part D, the minimum horizontal location reached. Those will be either the position at the initial time, that's a time of 0 from over here, the final time, that's a time of 5 from there, or any of the times in between when the velocity was a 0, and we have those here. There's 2 times when that occurred. So we're going to evaluate the position at the initial time of 0, the first 0 velocity time of 1, the second 0 velocity time of 3, and then the final time of 5. These will plug into the position function of t. So x of 0 will be 0 cubed minus 6 times 0 squared plus 9 times 0. 0 cubed is 0, minus 6 times 0 squared, which is a 0, plus 9 times 0, which is a 0. So 0 minus 6 times 0 is a 0, plus 0. This will come out to 0 in meters. X of 1 will be 1 cubed minus 6 times 1 squared plus 9 times 1. 1 cubed is 1, minus 6 times 1 squared is 1, plus 9 times 1, which is a 9. 1 minus 6 times 1 is minus 6, plus 9. 1 minus 6 is negative 5, plus 9 is a 4. It'll now be at 4 meters. X of 3 will be 3 cubed minus 6 times 3 squared plus 9 times 3. 3 cubed is 27, minus 6 times 3 squared is 9, plus 9 times 3, which is 27. We'll have 27 minus 6 times 9 is a minus 54, plus 27. 27 minus 54 is negative 27, plus 27 is 0, and we have 0 meters. And then x of 5, which will be 5 cubed minus 6 times 5 squared plus 9 times 5. 5 cubed is 125, minus 6 times 5 squared, which is 25, plus 9 times 5, which is a 45. 125 minus 6 times 25 is minus 150, plus 45. 125 minus 150 is negative 25, plus 45 is a positive 20. So, for part C, the maximum horizontal distance reached will be one of these answers, and if we look, the maximum was the 20, so it'll equal x at the final time 5, and that's 20 meters. Part D, the minimum, will be happening at actually two locations, here and here, the lowest of these, which is the 0, and it's happening at 0 and again at 3. So either x of 0 or x of 3, and either way it's at the 0 meters location. What the object is doing here is it's starting at a time of 0 at a position of 0 meters. It's then moving over to a time of 1, and it's actually located at a 4 meter location. And then it's turning around and it's moving back, and it's reaching back to the 0 location at a time equals to 3. It's at the 0 meter location. And then it turns around again and it moves over to a time equals to 5 at the 20 meter location. For part E, we want to find the total displacement. That's where it ends up relative to where it began. How distant is the final location relative to the initial location? And that's found by just finding the position at the final location, x of 5, minus the position at the initial, which is x of 0. We've calculated both these. X of 5 was a 20, and x of 0 was a 0, so 20 minus 0 is 20 meters. That corresponds to this picture, the distance between right here and right here, how far apart those are from each other, and you can see that's the 20 meters distance. We call that displacement. The total distance traveled, on the other hand, is made up of the full distance, which is this piece plus this entire piece. We have 3 different pieces. And it's found by taking the absolute value to ensure they're all positive of the final x of 5 minus the turnaround time right before it, which was at the 3, plus the 3 minus the turnaround time before it, which was at the 1, plus that turnaround time minus the initial. We had 2 turnaround times in this problem at t equals 1 and t equals 3. Now we have each of these numbers. X of 5 is a 20. X of 3 is a 0. X of 3 is again a 0, and then x of 1 is a 4. And x of 1 is a 4, and x of 0 is a 0. This is representing the distances of each of the pieces. So we have the absolute value of 20 minus 0, which is just 20, plus the absolute value of 0 minus 4, which is negative 4, plus the absolute value of 4 minus 0, which is 4. These are each of the pieces. The 20 is this entire piece. It's the long piece there. The negative 4 was the backwards piece. That's the middle one there, where it's moving backwards or to the left. And the positive 4 is the first piece there. We can take the absolute value of each of these, and it'll be 20 plus 4, which comes out to 28 meters. So it traveled a distance of 28 meters, but only displaced 20 in the end, because part of the time it was moving backwards, which is a negative displacement, but still considered a positive distance. Part G is the acceleration as a function of time. And the acceleration as a function of time is the derivative of the velocity as a function of time, or therefore the second derivative of the position as a function of time. The velocity is in part A. If we take the derivative of that, the first term is a power rule. Bring down the power, multiply with that 3, subtract 1 from the power. The second term is a constant times t. The derivative will be the constant. And then the third term is a constant with no t. The derivative is a 0. There's our acceleration function, 6t minus 12.